Okay, so we're over here. I again do not have that much to cover today. I'll probably finish what I need to do for section 3.5. So my formal lecture will be fairly quick. Tomorrow was a buffer day, quote unquote, with 7 holidays. It just means I can give you more time for the quiz. Okay, so I'll finish the formal lecture today fairly early, then let you ask questions. So you can plan ahead now. After I'm done lecturing for the first half of class or something like that, then I'll let you ask questions. And if there aren't any questions, we'll just leave, and that's about it. So tomorrow, I'll probably sneak in very beginnings of 3.6, and then let you have the hopefully the majority of class, hopefully half an hour, 25 minutes, half an hour, something like that, to do the quiz. Yeah, more than likely give you a rational function, and you have to do the whole works, analyze where the intercepts, maybe is there any symmetry, what happens when x goes out to negative infinity or positive infinity, what happens when you get close to an asymptote, does it shoot up or does it shoot down, or one side goes up, one side goes down, something like that, okay? Maybe I'll give you an example of what I might give you. The section on rational functions, yeah, so like 3.4, and maybe stuff like this on page, what, 169? Right, so I might have you graph something like 17 through 27, or actually 11 through 27. Those might be fair game. And maybe one of these up there, or like 41 and 43, or 37, 39. Okay, so they take a while. They take a while to do, so I'll try to give you a lot of time. Just as normal for quizzes, I'll break you up into your breakout groups. Your breakout group will normally have either 3 or 4, but you don't have to finish in class. You have the whole weekend. It isn't due until we start the next class, which will be Monday at 9:10. So you can talk about it with your breakout group teammates, but if you don't finish, that's okay. Now, if you want to turn it in early as usual, that's fine, or you can turn it in over the weekend, Saturday or Sunday is fine. But the deadline is the next class meeting, which will be Monday at 9:10. That's the way quizzes normally are. Okay, so very low pressure. I would say you don't really have to study for it. Just wait until I give it to you. Use your book, use your notes, talk about it. You got the whole weekend, and submit it by Monday, but you can submit it earlier also. Okay? All right, so that's what's going to happen tomorrow. All right, so for today, I was going to knock off the rest of what I was going to do for 3.5, and then be prepared for questions. So if you have any questions, be ready for it after I'm done. And if not, we're done for today. Okay? All right, so let me switch over to this. Okay, problem number 15. F of x equals x minus 1 to the 1/3 power plus 1. Okay. And this time we are going to graph it. Okay, so from the end, sketch the graph, label the axis intercepts, x-intercept, y-intercept, and if there are any asymptotes. Okay, so for 15, the base function, the basic function you want to think of is x to the 1/3. That's your cube root function. Okay, you should already have some feeling about the cube root function, but I'll show that to you again. Anyway. All right, so I have it in red, but x to the 1/3, you might recall it means cube root of x. Okay, so the one that I have in red is x to the 1/3 cube root function. Now I didn't make a table, but I'll just play along with certain points. What's the cube root of 0? 0. What's the cube root of 1? 1. Okay, the only other nice number that I'll plot is 8. The cube root of 8 is 2. So 1, 2, 3, 4, 5, 6, 7, 8, 1, 2. All right. And you notice you can also have negatives. Okay, so I have some negatives here. So the cube root of -1 is a nice number. It's -1. Okay. Because -1 cubed, -1 times -1 times -1 is -1. Okay. And then way out here, I have -8, comma, -2. 1, 2, 3, 4, 5, cube root of negative 8 is a real number. So remember, you can take the cube root of a negative number. You cannot take the square root of a negative number, but you can take the cube root of a negative number. The cube root of negative 8 is negative 2, because negative 2 is the object that you cube to get negative 8. Negative 2 cubed, negative 2 times negative 2 times negative 2 is negative 8. Oops. All right, so the thing that I have in red is the cube root function. Okay. And then we've seen this before. What's the effect of replacing x by x minus 1, and then outside plus 1? Okay, the x minus 1 like that moves the graph 1 to the right, and then the plus 1 means moving 1 up. Okay, so 1 to the right and 1 up. So 0, 0 moves over to 1, 1, which I actually already have in the graph. Negative 1 moves to the origin, which I still have in the graph. Okay, but the others also move up 1 and over 1. So I have the green graph, as it turns out. Okay, so the final answer would be the green graph that I have. You shift over to the right 1 and up 1. Okay, now for intercepts. Well, it looks like it's still the origin. Okay, 0, 0, and that's the only one. You can double check what happens when you plug in 0. 0 minus 1 is negative 1. Cube root of negative 1 is negative 1. And negative 1 plus 1 is 0. Okay, so that's the only intercept. And there are no asymptotes. This thing shoots as high as you want, as low as you want. We don't get close to any one line, so no asymptotes this time. Okay, 17, which you can see last time I did this, I messed up. F of x is negative 2 times x plus 1 to the 2/3 minus 2. All right, so the first thing I'm going to consider is what happens to x to the 2/3 power, because we know what happens with this, right? X plus 1 moves the graph 1 to the left. Okay, negative 2 means 2 down, and then negative 2. Okay, so the 2 makes it go steeper, and the minus just reflects across the x-axis, so the positives will become negative. All right, but first let's consider just the base function x to the 2/3 power. X to the 2/3. Okay, now 2 is the power, 3 is the root. Okay, so you may think of it as either of these situations here. Okay, it's either the cube root of x squared or the cube root of x first, and then you square it. Okay. Either way, let's see, you're allowed to plug in any real number. If you were to do this first, suppose you plug in a negative, well, you're going to square it, it's positive, then you can take its cube root. If you do this first, well, it means you can take the cube root and then you square it. So the domain looks like it's going to be all real numbers. Okay, now, since I am doing a cube root, okay, I'm doing a cube root, and for calculation purposes, this one's a little bit better. I'm only going to do numbers that have nice cube roots, namely 0, plus or minus 1, plus or minus 8, plus or minus 27. This is going to be an even function. Okay, you can look, especially right over here. If you replace x by negative x, you get the same thing back, which means you have an even function. Even functions have what kind of symmetry? Even functions have y-axis symmetry, which means you're going to get the same thing whether you plug in plus or minus 1. I mean, take a look. If you put in either a 1 or a negative 1, when you square it, it's still 1, right? Likewise, if I plug in either an 8 or a negative 8, I get the same thing, and same thing with plus or minus 27. But for calculation purposes, it's easier to do this first. And why am I picking these weird numbers? Because they have nice cube roots. Okay, see, if I were to pick 2, right? I don't know what's the cube root of 2. I don't like 3. I don't like 4. But 8's going to be nice. Okay, so here's my little chart. Okay, plug in 0, 0, 0, 0. 1. Cube root of 1 is 1. Square root is still 1. Okay. 8. Same thing works for negative 8. Okay, what's the cube root of 8? 2. If you plug in -8, cube root of -8 is -2, but when you square it, you still get the same thing, 4. Okay, and then 27, cube root of 27, 3. 3 squared is 9. All right, so here's my little mini table. I didn't bother going out to 27, I only went to 8. Okay, so temporarily ignore this stuff. I'll just use symmetry later. Okay, so 0, 0, 1, 1, 8, 4. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. That point's way up here. All right, so x to the 2/3 right now is like that. And now I'll just use symmetry. Since I have symmetry with respect to the y-axis. Whoops, dropped my pen here. We've got this thing over here. All right, so that's x to the 2/3 power right now. Okay, then the progression is, I now decided to do -2 x to the 2/3. Okay, so in red is the original x to the 2/3. 2 would make it steeper. So imagine this one, if I could sneak it in like this, it would be steeper. And then the negative will make it bounce across the x-axis. So the thing that I have in green is supposed to be -2 x to the 2/3. It's steeper and it only goes down. Okay, all of these were positive, right? These are all positive except for the origin. So if I multiply by -2, they're all going to be negative except for the origin, and it's a little bit steeper. All right, so the green one is -2 x to the 2/3. And then from what we said earlier, this moves the graph 1 to the left, 2 down. So it has the same shape as the green, just move 1 left, 2 down. So all I did was move the origin. So origin 1 left, 2 down is the point -1, -2. Okay, there's -1, -2, and it goes down like that. So this is the final graph, the thing that is in blue. -2, comma, x plus 1 to the 2/3 minus 2. All right, then again, it asks for any asymptotes. There are no asymptotes. The graph is not getting closer to any line or anything like that. It does look like I have an intercept. There's no x-intercept. It never touches the x-axis. It looks like it touches the y-axis. So how do I figure that out? Y-intercept means plug in x equals 0. Okay, so if I plug in 0 right here, 0 plus 1 is 1. 1 raised to the 2/3. 1 raised to anything is 1. So I have 1 times -2, -2. Minus 2 is -4. All right, so this point right here must be 0, -4. So y-intercept. And there's no x-intercept. You can see from the graph that can't happen. All right, folks, then just one more, the last one, and then I'm done. It's not even 9:30 yet, but this one's going to take a little bit longer to develop. Okay, so don't get your hopes up too high, but only a little bit. Okay, we will finish early, but this one will be a little bit longer. X to the -1/2 minus 2. Okay, something to keep in mind. What does x to the -1/2 mean? Okay, 1/2 means square root, and the negative means put it in the denominator. Okay. And again, for the homework assignment, skip 23 on. I mentioned that to you before. All right. Skip 11 and 23 on. All right, now I apologize. Last time I did this, I messed up completely. I made it a plus. That's a minus. It's a pretty big minus. You can see I originally put plus. Then somebody in the class pointed out, hey, they're not pluses and minuses. So, you know, that's my feeble attempt of trying to make them all minuses. But anyway. All right, so x to the -1/2. So it means 1 over x to the half, which is 1 over square root of x. Okay, so remember, if you have a fractional exponent, the number on top is the power, The number on the bottom is the root. So the exponent is 1. Well, if the exponent is 1, you don't have to write it. 2 means square root. And again, if it's a square root, you don't have to write the 2 there. Right? So the convention is if you just write it like that, it means there's an understood 2 there, right? If it's cube root, you have to put a 3. Fourth root, you have to put a 4. Fifth root, you have to put a 5. But for square root, just leave it like this. All right, so the numbers I was going to pick are first going to consider just 1 over radical x. We should work on this. Then what's going to happen with the minus 2? That just moves the graph 2 units down, 2 down. All right, so I'm only going to look at y equals 1 over radical x first. Okay, just that. Okay, and one thing I noticed, I'm not allowed to plug in any negative. I'm not even allowed to plug in 0 because then you'll be dividing by 0. Okay, and I'm only going to plug in stuff that comes out quote unquote nice. Okay, nice square roots. So in my table I have 1, 4, and 9. I also have 0.01 because I want you to see what happens. See, I'm not allowed to plug in x, but I can plug in numbers that are just a little bit bigger than 0. I cannot plug in 0, but a nice number to plug in would be 0.01. Okay? Because the square root of 0.01 is 0.1. 0.1 squared, 0.1 times 0.1 is 0.01. All right, so here we go. Okay, again, I'm only looking at this now, so ignore that for the time being. Plug in 1. 1 over square root of 1 is 1 over 1, which is 1. Okay. 4. 1 over square root of 4 is 1 over 2, 1/2. 9. 1 over square root of 9, 1 over 3. Okay, so when x gets bigger and bigger, the y values are dropping considerably. Okay. And then, remember, you're not allowed to plug in 0, but I can plug in 0.01. Okay. The square root of 0.01 is 0.1. You can try it in the calculator if you want. But 0.1 times 0.1 is 0.01. Or if you want to say the equivalent in fractions, that's 1/10 times 1/10 is 1 over 100. 1 divided by 0.1, 10. Okay, so it shoots up pretty big. So here we go. Here's 1, 1. 4 comma a half. 1, 2, 3, 4. It's kind of hard to graph it. I just go up a very little bit. Then 9 comma 1/3 is even lower. 1, 2, 3, 4, 5, 6, 7, 8, 9. I just go up a tiny bit. So over here it shoots like so. So the x-axis is an asymptote. But if I plug in a number real close to 0, like 0.01, it's way up at 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the graph shoots like so. Okay, so now we just move the graph 2 down. Okay, so the easiest thing for me to do is take the key point 1, 1. So what happens if I move 1, 1 down 2 units? I'm at 1, negative 1. And I just do the same graph. All right, so I do something like that. All right, this time I do have asymptotes. Horizontal asymptote, HA. Remember, you always have to put the y equals or x equals. Okay, again, if you want a memory trick, K, H-A-Y, and VAX, V-A-X. Okay, so I do not accept as full credit if you just give me -2 and 0. You have to say y equals -2. That's the equation of a horizontal line. X equals a number, x equals some constant. That's the equation of a vertical line. All right, well, in the original graph, 1 over radical x, the horizontal asymptote was the x-axis, which has the equation y equals 0. Move it down 2, and you have y equals -2. So the horizontal asymptote, y equals -2. Then you must write the y. Or even put it on your cheat sheet if you want, hey, H-A-Y, and VAX, V-A-X. Vertical asymptote was x equals 0, the y-axis. If you move the whole thing down 2 units, it's still going to be x equals 0. All right, so there we are. Okay, and then the intercepts. X equals 0, impossible. You cannot divide by 0, so there's no y-intercept. Remember, y-intercept means x equals 0. X-intercept means y equals 0. Okay, it looks like this graph is going to touch the x-axis or y equals 0. So I should be able to solve for that. So it doesn't look too bad. So where's here? So y equals 0. Set 0 equal to 1 over radical x minus 2. Okay, add 2 to both sides. Okay, so if I add 2 to both sides, it looks like this. 2 equals 1 over radical x. Square both sides to get rid of the square root. So square, square. 2 squared is 4. 1 over radical x squared is 1 over x. Okay. And you get x equals 1/4. All right, so 1/4 comma 0. So y equals 0 means x-intercept. Okay. You can do this algebra pretty easily. If you multiply both sides by x, right, you get 4x equals 1. So divide by 4x equals 1/4. Okay. Now, I'm not sure if you've heard of this before, but whenever you get something that looks like this, you're allowed to just switch these two. These two can just switch. In other words, just switch the 4 and the x equals 1/4. Okay. Have you ever seen that before? Okay, I got time, so I'll dig a little deeper for that. Whenever you have A equals B over C, you're allowed to just switch these two and say C equals B over A as a shortcut. And I'll give you a justification of that again. So A equals B over C. Okay. If I were to multiply both sides by C, these cancel out. CA equals B, right? And then divide both sides by A, cancel, cancel. C equals B over A. Okay, so I'll let you do that from now on. So if you've heard of it before, great. If you've never heard of it, well, you learn something new. So anytime you see something like this, a number equals a fraction, you're allowed to just swap these two. C equals B over A. Now, if I show you an example from arithmetic, I'm sure you would get it. All of you would get this just from your times tables and division facts. Example is 4 equals 24 over 6. Okay, we all know this, right? Okay. What happens when you switch these two? 6 equals 24 over 4. You say, oh yeah, that's true. That's basically just a result of the commutative property of multiplication, right? So here it's obvious, right? 4 equals 24 over 6. So if I switch them, 6 is equal to 24 over 4. That's an exact application of this. We maybe don't recognize it because all you see is letters, but if you put numbers, it's pretty clear, right? So you've been doing stuff like that before, back in arithmetic, right? 3 is equal to 15 over 5, right? And then just switch them. If you switch these two, it says 5 equals 15 divided by 3. And then, yeah, it works both ways. So you can use that shortcut from now on. Anytime you see that, you're allowed to just switch these two and get the answer. Okay. So suppose you get something like this. 5 equals 21 over x. Then I will let you immediately go to x is equal to what? 21 over 5. Okay. That's switching rule. Otherwise, you could go slower and say, oh yeah, multiply by x, divide by 5. But you may do this as a shortcut now. Again, when you write it like this, it's pretty clear. And here is the justification of that rule right there. Okay, so that's a little extra tidbit that I thought I would share with you. Okay, so I'm done, folks. So let me stop sharing. And I will let you ask anything, and if not, we can call it a day already. So let me check the chat box. There's nothing in the chat. And, all right, so you're welcome to unmute yourself and ask me a question or put it in the chat. But if you don't have anything, we're done. Tomorrow, I will start a little bit of the last section, complex roots. I won't go that far because I want you to have as much time as possible to get in your groups and work on the quiz. I would say, don't study for the quiz. You don't have to study for the quizzes this semester. Um, I don't make that promise during the regular semester if we were meeting on campus, but for this semester, that's true. Okay, anybody want to ask anything? Give you a little time, checking the chat box. I don't hear anything. That means you guys are all content. Okay, you're content, I'm content. All right, so tomorrow I'll lecture a short while on the beginning of the last section, and then we'll take our quiz, and that'll be it for this week. All right. Okay, that'll do it for today, folks. So everybody have a good day, and we'll see you next time. Okay, bye, everyone.